and that's how we figure it out, right?
Like, hold.
Sorry, I'm tired.
No, you're fine. That's sort of true. Just give me a second. I'm gonna erase all of that on the board and go start from scratch. All right. So your face is a lot of numbers. Got him. I wish my face was a lot of numbers. All right, let's hit. Good spot for that. Huh? Why am I throwing stuff around? Just show his boss.
He's also trying to practice being a ball coach. Dodge wrench, you can dodge a ball.
I'm erasing this. You want to take a picture real quick? So Thomas has it for the game design.
Is it not so good?
It is, but he's got his energy coming up.
That's a lot of smiley faces.
Faces a lot of smiley faces. One in doubt, I always. You good?
There's like a game on RC that's like Ninja Warrior.
Yeah, I mean, I will say with all of that chain they use this year, there's a lot of pirate games.
Yeah, I know. I heard about that.
Which I was shocked at.
I know, it just came out of nowhere. But
Face came out of nowhere.
Yeah, that is kind of true.
Got him.
Your favorite insult? Your face?
Kind of is fun to say that. It's also easy, but really fun to do. It's just needs to be protected at home.
Very creative.
You can't tee me up like that, Sandy.
Huh?
Nothing.
Ever saw that fourth stuff?
I knew that was going to happen.
Math.
Whoa. I left my mask at home, so I just borrow one from school.
Yeah. So it sucks.
You had the same problem.
Never saw. Tell Cody he got sucking disease.
He's got sucking disease?
Yeah. There's no explanation. You don't even know what it is. Just tell him you got it.
No, I'm not going to do
the smiley faces.
He knows what it is.
Well, I don't know what it is.
You know what? You know the inside joke?
No.
Okay. I was going to say, like, how would you know that?
I don't know. That's my point.
I don't know that either.
Okay.
All right.
No, just like.
2 lines.
Those are called parallel lines. All right, so I'm going to make the triangle, the truss from the PowerPoint, okay? All I'm going to do is remake it on the board. Okay, you guys are going to help me.
Sweet. 2 plus 2 is 4.
Hold on.
That is a good marker.
All right, so A, B, C's in the middle or at the end?
No, D is in the middle.
D's in the middle?
C is in the middle.
C's in the middle?
D is at the
D
end.
is in the middle, C is at the end.
C's at the end.
Yeah.
Okay, I know.
Short side is 3, long side is 7, and then it's 4 tall.
All right, so I know that this is 4 tall. I know this is 3, and this member is 7. Everybody agree with that?
Yes.
From A to D, the distance is 3 feet. From D to B, 4 feet. Okay, so we're so good. Also, we know that this is a pinned force, and this is a roller joint. Sorry, pin joint, roller joint.
Yep.
Okay, so far so good. Everybody happy with that?
No, it's not straight.
500 down.
Who cares?
Oh,
if it's
yeah.
not
Yeah, there's one more.
That's 4 ways. Oh.
So I'll use this for reactionary forces. So 500 force down. Okay, can everybody see that okay? No. Does that not come up?
No, that
People in virtual land, can you see this okay?
For the most part, yeah.
Virtual lands is just a field.
Okay. So that's 500 down. Now the last thing we got to do is set up our reactionary forces, okay? So how many reactionary forces does this have? And in what direction? It has 2, right? Y and X. So far so good? The Y is a reactionary force at what joint? A. It's at A in what direction? Right. Reactionary force at A in the Y direction. RAY. So far, so good? So this force would be what?
Reactionary force.
X.
RAX. Everybody in virtual land okay with that?
Yeah.
Cool. C has a roller, which means its only reactionary force would be in what direction? Perpendicular to the rolling, right? Yes. So it's going to go up in RCY. That's reactionary force. So far, so good? Yeah.
You mean like it's turning upwards? The roller itself?
So here's what happens. If I stand on a beam, okay, hold on.
You should have put a glass in there.
I know, I
That magic trick. Or you couldn't have busted it.
All right. So I'm standing here. I'm 500 pounds. I'm not. So I'm standing here, people in virtual land. I'm standing in the middle of the table. Okay. Is the table moving?
No.
Yes. It's very wobbly.
No. So let's say this is a pinned. Thank you. This is a pinned joint, right? So that side is not moving ever. Does that make sense?
Right. Yep.
This side is a roller joint. So if I'm standing on it, let's say I'm bouncing on it, what's happening here? Is this side moving?
No.
No, it's pinned, right? It physically can't. What's happening here?
This way.
Because the table itself is bowing in and out when I go up and down, this is physically moving in and out. It's rolling. Does that make sense? It's
It's
actually,
very wobbly.
it's the same thing that earthquake buildings have, that they are not structurally perfect, that they wobble. So when the wave hits them, the wave of force hits them, they actually wobble and then don't crack or crumble. Same thing here with the roller.
Go
The
with
roller
the
goes
flow.
with the flow. Huh?
I'm not saying,
On a
I'm saying
very
it's
windy
like
day,
stairs
but there is-
on the structure. Like if you're standing on top and it goes sideways,
Well, you wouldn't feel it. It's so slight. But the point is, which way am I not moving? Theoretically, I could be moving a little bit in X, right? Because I'm rolling that way. But I'm definitely not going up and down, which is what that RCY does. Does that make sense? Does that answer your question?
What if the roller rolls like out of position?
If it rolls out of position, you probably have a complete failure, catastrophic failure at that point.
what happens when it rolls on a hill?
So it rolls down a hill.
That's a car.
Well, if it rolls up a hill, you have a weird situation that you should probably figure out. Okay. So does this make sense to everybody so far?
Pen on the ground.
Yeah.
Pen on the ground. All right. So the first step, yes.
Oh, you ever see that? It was like an old, like they recorded it. It's like that bridge. That was like doing this.
Yeah. Do you know why it was doing that? And it finally failed. I mean, it was crazy waving.
Yeah.
They just did that because they actually didn't have slits in the side. So when the wind hit it, it actually hit its harmonic value, that it hit it such a way that it actually matched the vibration of the bridge or some version of that. And once it hit it, it just started spiraling out of control. So now bridges have little slits in them to let the air pass. Because otherwise it just becomes a sail.
I don't understand it.
I don't understand
A
either.
concrete sail.
Yeah. All right. So the first thing we have to do, does anybody remember?
Wait, what?
The first thing we have to do for this.
Set up your reaction.
So we have to deal with the reactionary forces. Before I solve, because my goal is to figure out how many forces and what magnitude are at A, B, D, and C. But before I can figure out what all the forces at C and A are, I have to figure out all the reactionary forces. Yeah. I have to find the sum of all of my moments. What's a moment again?
What they said.
Whether it goes
So a moment,
clockwise or
I'm just going to put this up
counterclockwise.
here just so we can remember. A moment is equal to what? Force times distance, right? Distance to what?
Distance to your reactionary force.
Distance to the pivot depends on the reactionary force, and it's always perpendicular, right? So in this case, where's my pivot point? A, and how far is this in the perpendicular direction? 3. Okay, does that make sense? B is in what perpendicular direction?
0.
It has something being pulled down, not to the right. If I had a force over here, right, let's say I applied like a 300-pound force this way, then what number would I use for my moment?
For your moment,
It would be perpendicular, so I'd be using 4. Because that's my pivot, but now I'm up. But we don't have to deal with that, thank gosh. All right? So we're just going to deal with the one force right now. Okay, everybody happy so far?
Yeah.
All right, so I'm going to sum up my moments. And if I do it correctly, all my moments should be equaling what?
0.
0. Why?
Because then that would be equal failure.
What?
It won't.
It'll be in
Oh,
equilibrium.
yeah, true.
Is this truss moving?
No.
No, if it was, it'd be an unsuccessful truss, right? It would be collapsing or floating into space. So because it's not moving, since it's not moving, okay, then all the moments should be equal to 0. So now we have to use the right-hand rule, which is take your thumb, point at your face, and you see which way, if something was to turn, if it turns and doesn't break my wrist, it's positive. If it does break my wrist, it's negative. Huh? So let's look at this force here. The moment at D. Is that going to be a positive or negative moment? So here, let me write it this way. We have a moment at A, we have a moment at D, and we have a moment at C. Everybody agree with that?
Yeah.
Technically, if I broke these down, it would be dA times force A, dd at force D, I'm sorry, times force D, and dC at force C.
Oh my goodness.
So let's just kind of do this. What's D for C? How far is C from the pivot point?
10.
10. Okay. 10 feet. What's D for D?
3.
3. It's 3 from the pivot point. Hold on. And what's D for A?
0.
How far is A from the pivot point? Well, it's 0. And I don't care what the force is then, the whole thing goes to 0. So technically the moment at A exists, but it's 0 because it's 0 from itself. Does that make sense? And the equation is anything times 0 is 0, therefore the moment goes away. Yeah.
Is there such thing as matching numbers which
I hate you. Sorry. Imaginary numbers exist, but that's not for this, right? No, because that would imply that we're not dealing with this real system. They do come into play in engineering, particularly electrical, but very rarely will you see it here, as far as I know. That's above my pay grade.
Huh.
So, all right. So A doesn't exist. So what 2 moments am I dealing with?
That one, that one.
That one and that one is the technical term. D and C, right? Which one's positive and which one's negative?
The D is positive and the
If-
C is negative.
Yeah.
He said the opposite.
It's negative.
D is
C is negative and C is positive.
the reason is which way is D pulling? If D was the only force on the system, which way would the system rotate if it could rotate around? It would be going this way, right? It would be going clockwise. Clockwise is negative. It breaks my hand. Does that make sense? This is negative.
It feels
So you say
but
that
that's how
Yeah.
from this, like this, so D going this way.
Clockwise is negative.
I see that goes from.
Counterclockwise is positive.
So I'm saying that's important. So confusing this hand.
Look at your hand. Okay, your thumb. Okay, rotate around your thumb so it doesn't break your wrist. That's counterclockwise. That's a positive rotation.
I see what I'm saying. But how you know it's negative?
How do I know you use negative? Go the opposite way. Does that feel not good? Does that feel like a negative outcome? That's negative. So if something was to rotate in that direction, that would break your wrist, such as, wait, yeah. So this derotates negatively, right? See how it's breaking my wrist? If I follow the force, it's going to wrap my hand all the way around my wrist and break it. D, on the other hand, goes which way? It goes counterclockwise, which feels like a positive sensation, right? Does that make sense? That's not going to send me to the ER. So far, so good?
Yes.
Which is definitely a positive outcome. Power school, as many of you are aware, blah, 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 services or situation, blah, blah, blah. All right. Any questions on this? So I have 2 moments. C is positive, D is negative. So far, so good? So I'm going to add them together. I'm going to get negative D plus positive C, otherwise known as MC minus MD. Did I lose anybody with just rewriting the equation? Great. If I rewrote this in terms of each other, what would they be? I only want a relationship between the 2. I could just move this over and get positive MD. So I get MD is equal to MC. So far, so good? Yes. Now I start filling things in. MD is DD times FD which is equal to DC times FC. DD is 3, right? What's the force applied to D?
Negative 500.
Positive 500 right now. Because
Oh,
I
yeah.
changed my equation. Yes, you're technically right, but since I did it within the form of the moment, I don't have to worry about negatives anymore.
Okay.
Does that make sense, Chris?
Yeah, it does.
Okay. So is equal to DC, which is hubbing,
No, 10.
10, because I'm 10 from there. Okay, it's always from the rotation pivot point. 10 feet, do I know the reactionary force at FC?
No.
I do not, so I'm going to call it RCY. That's what I'm solving for. Does that make sense?
So you divide times 3 by
Simply divide by 10. So you get 3 times 50, which is 150. And that would be, I divided by feet, so the only thing left is pounds, which makes sense. RCY is 150 pounds. Now, using this, I can sum all the forces together, okay? If I sum all the forces, I have to do 2. I have to sum all the forces in the Y and sum all the forces in the X. Because I have an X and a Y, I still have unaccounted for. Let's do the Y's first. List all of the forces in the Y's. First of all, is this moving? No, so they're all going to equal 0. So list all the forces going on, every single one. Only in the Y. 500 down, which means what? Negative. Plus
150.
150 up, which is positive. RAY. That's all it is for that one. Okay. Now I'm just going to solve it for RAY, right? Negative 500 plus 150 is subtraction, right?
350.
Negative 350 is correct. Negative 350 plus RAY. Then I add 350 to both sides. And I get RAY is 350. Now, technically, you could already figure out what's going on in the X's, right? I had 500 entered the system. I've now accounted for both. All of my forces have now accounted for 500, so there shouldn't be any forces left. We can test that theory real quick. If I sum up all of the forces in the X, they should equal 0 because it's not moving. Name all of the forces in the X direction.
300 up, 150 up, 500 down.
Are those in the X direction?
Oh, yeah, 0.
Well, I don't know 0 yet. Name all of the forces that we have named so far in the system. Huh?
REX.
And then
That's it.
What's REX equal to?
RA.
Oh,
0.
it works. Yay. Does that make sense? Intuitively, it makes sense. Mathematically, it makes sense. It makes sense.
Physically, it makes dumb.
Physically, it makes you millions of dollars.
I have a question.
Well, hundreds of thousands of dollars. Yeah.
And
What happens instead of the 500 pounds that D would put up? I like that.
Ask me again.
What happens if the 500 pounds that B would be? Would it be the same thing? Or because it's at B, it's pushing down?
It would be, if it's pointed straight down, it would be the same so far. The difference is where the forces on the joints would end up when we start moving into that.
Okay, so that's the, all
As of right now, it would be the same.
right, that's the question. Just got it right.
So,
Simple answer is nothing would change right now.
Okay.
Yeah.
so if nothing is like moving in the X direction, we just assume it is 0.
You don't have to assume. Is there anything moving in the X direction?
No.
What about now?
Yes.
Yes.
What about now? If I change this to be off center, would there be an X direction?
Yeah.
Yes, there would.
But there is no off center. Everything's exactly 90 degrees or non-existent in the X.
Can we find some?
Okay.
No.
No.
Not right now. Okay, does this make sense for everybody? Yes. What? If there's just a 3D model, it is a 3D model. Are you asking a Cartesian system? Yeah. So you want to know in a 3D model, because that's what the world we live in. How would you apply this with a z-axis?
Yes.
You would have to sum up all the values in C as well. That's called a vector cloud, I think. I haven't dealt with a whole lot of that. I did it once in VQ, and that was about all I've ever done.
What's the
I used a model. I used a program to do it. Like very rarely would you start doing that by hand, but you could. You have to start using linear algebra for it, essentially, which is not a hard class. It's just time consuming.
Just tedious.
Here's what X, Y, Z. That's what you have to start dealing with. So you'd have trusses in 3 dimensions and forces being pulled in 3 dimensions, which is really how forces work. Like very rarely do you get a 2-dimensional force.
Will you ever have to do a 4th dimension? Just asking.
4th dimension always exists. It's time. The change in things is time. 4th dimension is more of a, what's it called, symptom of existence than it is technically a dimension, in my opinion. Because even if I'm dealing with 2 dimensions, I still have a change in time. So that would be the 3rd dimension in that case, which is a symptom of from here to here. This was t equals 1. This was t equals 0 and 1, right?
Yeah.
So I drew it and it existed in time on the drawing, but there's only 2 dimensions it exists in. So technically, the 3rd dimension would be time. But then once you get into time in the 4th dimension, then you have the distance between 2 3D objects, which is the wormhole. That's not.
Yeah. I kind of got confused because I thought time was like the 5th dimension.
No, is
So would Z be the 4th dimension then? And time would be 3rd?
symptom that is an actual.
Yeah.
You can't travel through it. I mean, you can in the sense that I can travel through forward, but not backwards. But it's not like spatial. Even the 5th dimension is traveling between 2 points in a hyperdimension in 3-dimensional space. That's when you warp it. You get a worm drive.
I had this conversation with Colin before. He confused the crap out of me really quick.
Well, yeah. Not so. M theory or string theory, what string theory used to be, predicts. I think it's 11 dimensions right now.
Yeah. I tried looking that up before,
Well,
but it's really hard to remember.
one's not time. Like time doesn't really work the way like they say it works. And
Yeah.
just like there's not 3 states of matter, there's 4. There's always that little. Wait a second.
I know a little kicker that they make.
But there's 5.
There's 5 states of matter now.
Yeah.
What's
What?
the
Absolute
Plasma?
zero, plasma, solid gas.
absolute 0 is a state of matter? Wouldn't
No,
it
it
be
was,
frozen?
it was
learned that in
warm
seventh
Einstein where it
grade.
gets so cold. It's
Wait,
the
wait,
opposite
wait.
of plasma.
Faces the opposite of plasma.
I wish.
Got it. Okay. So we have solved all of the forces so far acting on the system, correct?
Sure.
Well, either say yes or no. There is no sure.
I said yes, sure.
Yes, sure is a better
that's
answer
why I
than
said
yes, sure.
Not yes, sure.
Okay. We have 4 forces total. 1 was given. 3 were reactionary. We solved them all. Now we can move on. The thing that people get hung up on is I'm not solving for member forces. I'm solving for the forces at the joints. Okay. How many joints do I have? List them. I have 4. I have 1 here.
A, B, C.
Actually, that's more.
A, B, C, D, A.
So I have a force here, right? That's, I'm sorry, a joint here, that's A. I have a joint here, that's B. I have a joint here, that's D. And I have a joint here, that's C. Does everybody in virtual land see that? Oh, went the wrong way.
Yeah.
Okay. Let me make this bigger. D, B, C.
B still looks like a B.
That's fine. Yeah, I'll leave that. Okay. All right. How far is D from A?
3,
How far is D from B?
4,
How far is D from C?
7.
How do you know that?
Because we have to.
It's already given to you. Okay. So far, so good.
Free stuff.
Ben, does that make sense? You look confused. The values, the distances were given you in the original. I'm just transposing them here. Okay. So the last thing we have to do before we can even start is we have to set up all of the forces acting on any particular joint at any particular moment. So let's look at B. What forces are acting on B?
There is A.
Hold on, just how many forces at A?
3.
There are 3. How many at A?
2.
You sure?
1.
There's 4 total. 2 we have to calculate. Does that make sense?
Two and nine.
There's 4 forces total on A. D is pulling on A. B is pulling on A, and the reactionary forces from the wall are pushing on A. Okay? So far, so good?
Yes.
Okay. So here's what I'm going to do. I'm going to assume that every single force acting on a particular joint is always in tension. Now, what does that mean to the joint?
It's always pulling.
Right. So if this member is affecting A, which way would the joint be, or which way would the force on the joint be going?
Towards A.
Is this in tension at A?
No.
No, that's compression, right? So when I say tension, I mean that B is physically pulling A. So far, so good?
Yeah.
Okay, so this one would be what?
That would be facing towards D.
Right? This one, D would have here, 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 and here, 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 and here. Now,
Wait, wouldn't B have more going down too?
we've already solved it. I don't know where that.
Okay.
Oh,
Technically, yes, there's a 500 force going down, but I already know it, so I'm just going to kind of leave it off now. Okay. I will come back to it. It will be important, but not the most. So far, so good. So I don't want to overly confuse you. So I'm not going to overly constrain this. Okay. So now that we have that, I'm going to move this over.
Gotta oil it.
Yeah. All right. So all I've done is I moved the whiteboards around. Did I lose anybody in that operation? You never know.
How much?
You never know. Okay.
what's our next problem for it? Is it the whiteboard?
Okay, so I'm going to be very clear on what we're solving for. Okay, what I'm solving for, what I care about, what I absolutely want at the end of the day is AB. I want to know what AB is. Okay, I want it so that I'm going to put in purple. That way I'm not
Yeah, purple.
AB is the force pulling on A. Okay, that's what I care about. Okay, if I drew this as just anything, okay, I'm going to have AB. Okay, that is a resultant force. Okay, that force has what 2 things to it? No. Well, yes. Every force always has what 2 components? X and Y. I have an X. I have ABX. And ABY. Put together tip to tail.
So the
Does that make sense to everybody?
yeah,
Virtual land?
3 and 4.
All I've done here is I took AB, I've blown it up, okay, and I broke it down to its components, both X and Y. Just like we've been doing this whole time. Okay? So far, so good?
Yeah.
Okay. In order to solve for any of this, the first thing I have to do is figure out what this theta is. I have to solve for that triangle. Okay? Do I know anything about this triangle that could help me get to that theta? Yes.
You know that opposite is 3 and 4. Is that right?
But be very careful. I just notated this with forces, but you're using what? Distance, which is still true. Whether I'm dealing in forces or distance or goats or I don't know, anything, shirts, whatever, it's still going to be the same ratio. And that's all that tan is a ratio, right? Tangent theta is equal to opposite over adjacent. It's a ratio. Does that make sense? Doesn't matter if I use forces or distance or inches or miles or time or whatever. It's always a ratio. It's always going to equal the same thing. Yeah, Will? Okay. So how tall is this triangle?
4.
Is 4. And how wide is this triangle?
3.
I got that because it literally tells me these distances here. Okay. I'm looking for this. So I'm going to be using tangent, right? Tangent of theta is equal to tripping on acid, right?
Yeah.
On acid. What? Yeah. Some old hippie, call another hippie, tripping on acid. On is how big? That's opposite, that's 4.
3.
Adjacent is 3. How do I solve for theta? Theta is equal to the inverse tan or arc tan of 4/3, which comes out to, anybody? 57.
A number.
What you teach, that's a big.
57.69 or something. What?
I can get negative 1 over. I can get negative 1.
No. It's not everyone. It's the inverse of tan. What I've done is
You know what? 4/3.
to the inverse of tangent, and these cancel out, leaving only theta, and the inverse comes over here. It's the same thing as doing
53.1.
no. You're in radians.
0.92729.
What?
0.92729.
Oh, you're definitely in radians.
Oh, okay.
On the calculator, there's 3 options. Click on each calculator.
53. Oh,
That's what I
53.
said.
Sorry, I thought it was 57. I guess I'm wrong. So it's 53. So 53.1.
1/3.
All right, 53.1 degrees. Does this make sense? It's the same thing as saying x squared equals 9, solve for x. What do I do? Yeah, you take the inverse of it. So technically what I'm doing is if f of x is equal to x squared times this, the inverse, which is denoted by a -1, the inverse of x would be radical x. Does that make sense?
No.
That doesn't make sense? Okay, I guess we're doing this now.
No. I understand how to use it.
Well, no, this is going to be. Have you seen the term f of x before?
Yes.
All right, so let's say the function in terms of x is x squared. What's the inverse of x squared? If I want x squared out, what do I use?
Square root.
Square root. That's its inverse. The inverse notation is the function to the inverse, which is the function to its inverse is that.
Okay.
That's where this notation comes from. This is just the inverse of tangent.
Okay.
Does that make sense? And then I do it the same way. So if I want this, I'm going to do the inverse of the function, which is square root of x squared. I just do it to both sides. The problem is I don't write this anymore. So I would just go straight to this, which is what I've done here. I just skipped a step
Can't you just?
because I'm not doing this twice anymore. It's just too much time.
I can get 53.1.
You just calculate. I did art. Don't roll your eyes. I'm not going to do it by hand. I put in your calculator and I said arc tan or inverse tan. So you'll either see it as a tan or arc tan, or you'll see it as literally tan to the -1. Usually you have to hit second tan to get there.
Why does it say arc10?
I don't remember why it's called arc tan. Probably has to do with an arc of some type. I don't know. I'll have to look at it. That's a Google question. I do at one point, but I don't remember anymore.
Does it have to do with a unit circle or something?
Probably. I don't know. Well, the unit circle is a very special right triangle. That's all it is.
Okay.
Okay, so does this make sense how I got that angle? I can't do anything until I get that angle. Let's do one more. Let's find this angle, okay? Or this angle. Same angle. Huh? All right, tangent of 4/7. So tan theta is equal to opposite over adjacent, which is going to be tan inverse of, tan inverse of 4/7 is equal to theta, which is what?
29.74.
29.4.
74.
What?
29.7.
That really gross to me. You're right, though. It's important. 6 things matter. And this one's what, 53? Okay. So now that we have that angle, I actually did write 24. Okay. So we did all that just to get the angles. Now we have to actually solve for these forces. I'll show you how to do that. Okay. So, remember, what do I actually want out of this triangle? I want AB. I'm going to use AB's friend to get to AB. That's exactly what I'm going to do. So we're going to sum our forces in the y direction. I could have chosen x, but I'm not dealing with that right now. So I'm going to start by summing my forces, which should equal what? 0.
0.
Okay, and I'm going to sum them in the y direction. So I want, well, I know one of them, right? Is what?
That's 350.
350. So I got R A Y plus A B Y. Okay. Do I know either of these?
You know RA.
I know R A Y is 350. Right? So far, so good. A B Y is a little harder to find, correct? But now that I have this angle, I could use trig. 53.1. So, how would I find ABY in terms of what? I need two sides through triangle for this, right? What's the other side I'm going to pick? I want AB. I want AB. That's all I want. That's all I care about. I don't care about ABY at all, not even a little bit. Okay, I want AB. So I'm going to say 350 plus, if I want AB, so here, which function will give me both ABY, well, both, I'm sorry, which function uses ABY and AB using that angle? What? Sine is correct. Sine of 53.1, which is a real number, that's a decimal, it's a real number, okay? It's the same as pi or e or anything like that, okay? It's a real number, just a decimal, is equal to what over what?
ABY.
Opposite over hypotenuse, AB, oh, sorry, ABY, I don't know, over AB. All I want is in terms of AB, right? So what has to be by itself? Because I'm going to substitute ABY out. So I'm going to set this whole thing up to ABY. Let me explain. So I'm going to multiply by AB to get ABY by itself. Does that make sense so far?
Yeah. Okay.
That's gone. So now this whole thing goes in this equation, which is AB sine 53.1, which is a real number. Sine 53 is a real number, right? So now I can set this whole thing up and actually do it. So I get negative 350 is equal to AB times sine of 53 divided by sine of 53.1, which is what?
I don't know. I got
437.67.
437.67. Okay. Was that positive or negative that you got?
Negative.
It's negative, right? But this is not a negative force. That wouldn't make any sense. So what's wrong? My assumption that tension was the force. It's not tension. What is it? It's compression. So I'm going to redraw these as compression in both directions. So does that make sense? And we have solved AB.
And now we only have 1, 2, 3, 4 more.
Okay, it's a little easier than that. So hold on. Let me pull up my PowerPoint. Face is fun. Got him. Okay. Now, let's do ABX, right? Because what I really want here is AD. Does that make sense? We're going to sum everything in the X direction. Does that make sense? Okay. Make sure I'm doing this right. That's correct. it's negative. Okay. Does this make sense, everybody? Okay. We're going to do the exact same procedure, but now we're going to do f of x. So all of the forces in the x direction at A are what?
0.
Well, the whole thing equals 0 because it's not moving. That's true.
You have your reactionary force.
My reactionary force, so R A X. What else? Yep.
Is that it?
Actually, I don't need the reactionary force because the reactionary force is 0, right?
Yeah.
So technically it's there. What else is happening at AD in the x direction, right? A in the x direction, sorry.
It's
You have the part of the one.
That's 0, so that's fine. I have the part of the 1, and that part is what? Okay. If we look at A in the x direction, what's happening to it? What? It's heading to D. That's true. So I have AD. Okay, that's true. What else do I have?
DC or AC.
DC would be over here. No, I'm only looking at A. Nothing else exists.
Okay. I'm sorry.
You're fine. No, everything's automatically attached until I prove otherwise.
Isn't it just so is that in reach?
What? It is ABX. ABX also exists. The reason is I know that this is not complete, so there has to be a separate component, which is ABX. So far, so good? Everybody happy with that?
Yeah.
Okay. So RAX exists. It happens to be 0 in this case. It's not always the case. This time it happens to be 0, it goes away. So I'm left with AD and ABX. Any problems with that?
Wait.
Yeah.
How is REX 0?
RAX is 0 because RAX is 0.
Oh, okay.
We've already determined it was 0 before. So yes, when I'm summing the forces at A, I have to include it. But no, I don't have to go any farther because it happens to be 0.
Okay.
Not always the case. In this case, it's true. I can just remove it. Now, is everything correct in my assumption in my equation? AD is assumed to be in tension, so it's positive. That makes sense. What about ABX? I know this is negative. It's because it's going down to the left. What way does my X now go? Since this is wrong, everything is now going down and to the left. X is actually going to the left. So it's negative. Negative ABX. Does that make sense to everybody? Because if I actually look at the angle, in fact, this would also be negative. Why would also negative? Because now my entire system is going down and to the left. Down and to the left. Extra points for everyone can tell me what that's from. Down and to the left. Actually, it's back and to the left. Back and to the left. No way? JFK assassination? The JFK movie, the Oliver Stone movie. The Zapruder film? No one's seen this?
I might have. I don't remember. But I might have.
There's a scene where during the court case here, they're going into the he's using the Zapruder film. You guys know what the Zapruder film is? You guys know who JFK is?
Yes.
Okay, JFK was assassinated in Dallas.
Yes.
Zapruder was the guy who filmed it. Okay.
Oh yeah, I know that.
Okay, so the prosecutor in the court case is going through it, and he's looking at his argument. There's a shooter on the front lawn in front and to the right of JFK, right? So his argument is when you look at JFK's head at the final shot, it goes back and to the left, back and to the left. Leonardo Oswald was behind him and in the front, or behind him and to the right, which means that his head, the argument is forward and to the left, but didn't do that, according to this Oliver Stone movie. They have a lot of conspiracy theories, but there's a lot. Huh? Yeah. Right into his wife's lap. Yeah. It's terrible what happened. He actually lived for a while, not too long, but he made it to the hospital. I mean, he was probably brain dead on arrival, but they were trying.
Did he wrote a book and got like the
There was the first shot. There were 3 shots. The first one missed, or the first one hit him and the senator in front of him.
Yeah.
And then the second one missed, and the third one was the fatal shot.
Yeah. Is it a rifle?
It was a rifle. It was a Springfield, I believe.
Oh.
Well, it's such a big deal because even the leading marksmen couldn't hit a moving target. They couldn't even fire it as fast as they did because one of the cops on a motorcycle left his motorcycle microphone on. So it recorded a succession of shots. And even the leading marksman couldn't, because of the bolt action, they couldn't take aim, fire, rack it back, fire, rack it back, let alone having a moving target with debris in the way. It's just a big tree in front of the
I feel like that must have been like 3 people then, because
the argument is there were 2 shooters. I mean, there could be 3. There's another argument. There's the umbrella man was a signal man, but that was disproven because the guy came forward. It's like the umbrella is apparently a political statement against the Bay of Pigs or something in Cuba. I don't exactly remember what it was.
That picture where it's like experiencing that this girl like time travel. She had like it was like she's holding up a phone, but people were like saying, "Oh, that's like one of the shooters."
Oh, I've heard there's time travelers with phones. I've seen that argument before.
did you know there's a scene in
The more interesting argument is the fact that if time travelers don't exist, man, that means that we really screwed up. Because you think that once we get to a point, time travel would be possible. So either it's not possible, or there's no one alive in the future to come back. Yeah, think about that one for a bit.
You know, I was thinking about too. It's like aliens, like aliens were proven. Like there's no, we're done for.
bro, what if there's like
Because
one
if
person
they
that
count
actually
the
does,
The magnitude of the universe, there's like no way that aliens don't.
So that's the Fermi paradox, which is to say that there's so many possibilities that just should be taken as fact.
Well, because if they're like
But here's another problem with the Fermi paradox. It's the same along the lines of the time travel paradox. In fact, we don't have time travelers. Either really good at hiding or something terrible has happened. So what if there's a extinction level event at every stage of some point of evolution? So so either there's a supernova, there's some type of law that prevents an evolutionary step that allows for space travel. Either it's not possible, or every single species that reaches that point becomes extinct.
What if
Or
it's just like
overpopulation
they
or
jumped
something.
in a
what if it
different
just
timeline,
happens
broke
to
off
be like
ours?
Futurama?
That would be awesome. What?
I can go to space.
Okay.
Time travel, it just doesn't. They broke.
All right, let's get back to this, guys. That was a nice little tangent. All right.
I like that. Yeah, I know.
All right. So back to this. We set this up. Do I know how big AD is? I do not. Thank you. Equals AD minus, do I know ABX? I sure can.
Yes,
How would I find ABX?
ABX. You have data.
I have theta. Theta is 53.1. Is there a way to use trig to find ABX?
Oh, yeah.
You also don't have.
Okay.
I have the hypotenuse, which is AB, and how big is that?
Cosine.
So I have the hypotenuse, I have the adjacent.
Oh, yeah.
Which one uses another hippie? Cos, cosine of 53.1 is equal to ABX over AB, which is 437.67, right? So I get 437.67 cos 53.7, no 1, sorry. All right? And then I just add it and do the math, which comes out to what? I want to solve for this. What is it? 262? 262 point what?
7-9 rounded.
79 rounded sounds good to me. AD. Is that positive or negative?
Negative.
Positive. I added this to the other side.
Yeah.
It was negative, then I added it.
Oh.
Because this force is positive. It's positively in compression. The only reason it's negative is because the x is pointing to the left. Does that make sense? So when I substitute in this positive value, it doesn't negate the subtraction sign. So very important. So this actually is in tension at AD. So AD here is Hold my purple stuff. You stole my purple marker.
What?
So this is positive 262.79. So I successfully solved all of A. Okay? And partially of D and partially of B.
So how do you take those partials and solve for B?
Great question. What's the next easiest thing to solve for? This is pretty easy because I have only two unknowns. C is going to be easier. Let's start with C. That way I solve for here, I only have one left. And when I get one left, I only have one left. Does that make sense? I am going the path of least resistance. No, to Xander's next question, I cannot start at B. There's too many unknowns. I have to do this strategy. Okay. Does that make sense? I could have either started at C or A because they're equal, right? I don't know two things. I don't know two things. Even though there's 4 forces here and 3 forces here, I still don't know two things. So I have to start there. Here I don't know 3 things. Here I don't know 3 things. Can't do it. Okay. Almost done. What?
Yeah, do it.
Well, don't do that anymore. Not doing trust calculations, buddy.
Yeah, it's not funny.
That was funny. Okay, so I'm going to start at C. I'm going to erase all this and see if we can do it. Okay, you guys are going to help me with this one. Yeah.
Well, we'll start with what?
What? Okay, so I have one other force on here. I should put a reactionary force at Cy, and that is equal to what, 150? Yep. Okay, so I want to know AC, right? So I'm going to draw AC down here.
Wait, you want to do BC?
Yep.
There you go.
Testing you. You all passed. Well, I guess they passed. BC. And I know this angle because we did it earlier, 29.7 degrees. Okay. So far, so good. I have here BCX, BCY. Okay. So first thing I'm going to do is what?
Sum up all the forces.
I'm going to sum up all the forces in what direction. I don't really care which one you want.
BX.
In the what?
In the Y.
I said the X, Y. I was like, pick one.
The Z.
Sum all the forces in the Y should equal what?
0.
0 because it's not moving. Where are my forces in the Y?
You have your reactionary force, which is 150.
Okay. I have a reactionary force.
That's a great number.
Reactionary force at C in the Y
You have-
plus
you have-
BCY.
Yeah, what she said.
Okay. Do I know any of those off the top of my head?
RC.
Reactionary force.
I know the RCY is what? 150. BCY, however, is going to throw me. Is there a way to solve for BCY? Remember, do I want BCY? No, I'm only using BCY. What do I want? I want BC. So how do I get BC using BCY? Which trig calculation? Which trig calculation would give me both BC and BC and BCY? Sine is correct. Does that make sense, guys? I'm telling you? Gladio?
Yeah.
Which trig calculation would use both BCY and BC? Huh? Cosine? Cosine uses the opposite. Does it? Because this is the opposite of my angle. And what's this? The hypotenuse. Which one uses the opposite hypotenuse? Old hippie. Some old hippie. So I'm going to use sine here. I'm going to say that sine of theta, which is really 53. Oh, I'm sorry, not 53 anymore. That's 29. 29.7 is equal to the opposite, which is BCY, over BC. Solve for BCY to get rid of it. Yeah. So I'm going to get BC times sine of 29.7 equals BCY. This gets substituted into here. I get BC times sine of 29.7, all equals 0. Does that make sense? How I got that little equation? Remember, I have BCY. I don't care about BCY. I can go jump off a bridge for all I care. Yeah, no, I'm not going to actually make it jump off a bridge. Oh.
That's terrible.
BCX, I'm not using BCX right now because I've only summed them in the Y's.
Does it sound like a band?
Huh? There's always a BCX. Even when X is 0, so if I have a vertical one like this, there technically is an X component. It just is how big?
0.
0. Good question. All right, so now all I gotta do is solve for BC, which is what I want. Okay, so far so good. So I would do this and I would get, can I delete this? Is everybody happy if I delete this? Is everyone cool with that?
It would be 150 divided by 9.
Say faster. Thank you so much. So I get 0 is equal to 150 plus BC sine of 29.1, which again is a real number, just a decimal. Okay, it's like pi or e or something. Subtract that over here. So we get negative 150 is equal to BC sine of 29.1 divided by sine of 29.1. That's a cancel completely because it's a real number, right? So you get negative, whatever this is equal to BC. So what's BC?
Negative 308.429.
Say it again.
Negative 308.4.
308.4. One's fine. What?
How are you going to change it from 0.7 to 0.1?
What are you talking about?
29.7.
This one?
That's 29.
With a simple stroke of my pen. Aaron,
In that case, it's negative 302.7.
302.7?
Yeah.
Thank you. I like this having like a personal Jarvis over here. This is nice.
Yeah.
All right. So BC over here is actually how big? 302.7, but it's in compression now. So it's actually going this way, and this is going this way. Does that make sense? Okay. So the last thing I gotta do is sum all the forces in the X. Right here. So all the forces in the X direction. So you get 0 is equal to BC and BCX. Yeah, DC.
Why did you say BCX?
I didn't say BCX, did I?
You wrote it.
No, this is a lot of math, man. I'm lucky I'm keeping all these. I'm dyslexic.
Is that DC or BC?
Is correct. It's present. Huh?
Is that DC or BC?
It's DC plus DCX.
Okay.
No, I was right the first time. The animals. It is BCX. BCX. BCX is the X component of joint B. Yeah, I was right the first time. You made me question.
Wait, but what about D? Is it still DC?
DC is this one.
Yeah.
Yeah, so that's DC here.
But how do you do BCX?
Huh?
How do you do BCX? Is it the same thing as BCX?
DCX is the same as DC because it's horizontal. Does that make sense? You're overthinking it now.
Okay.
DC.
There wouldn't be a DCY, would there?
Y is 0. DCY would be the same as DB. Does that make sense? Okay. So here I get this. Do I know DC?
No.
No, do I know BCX?
No, you know BCY.
Well, I can find it. So BCY, right? Well, actually, I don't care about BCY. I never actually solved it. I don't care. But I do have BC. So which trig function uses both BCX and BC with that
Cosine.
cosine? Adjacent hypotenuse. Another hippie. Again, I'm using this angle. It's the only angle I know. Adjacent hypotenuse.
Oh, let's think about adjacent.
Adjacent is the only. So this is the number one people screw up with trig. technically every angle has two adjacent sides because it's anything touching. Notice that this one doesn't touch it, so it's opposite. Easy to do. That's the easiest one. The question is, which one of these is really the adjacent? Well, I named one of them a very special name, which is what? Hypotenuse. So if this is the hypotenuse, this one has to be the adjacent. Adjacent. This one's the opposite.
Okay.
The opposite is the only one that doesn't touch the angle.
Oh, okay, all
All right. So here I get cosine. So cos, you guys see the trend here yet? 29.7 is equal to BC x adjacent over hypotenuse. Solve for BCX by multiplying. You guys see the trend?
Same thing, different letters.
It's the same thing, different letters, and it's always a single multiple equation. Okay. So here I get DC plus BC cos of 29. No, wait, actually no BC. How big is BC? 302.7. Is this going to be positive or negative, this force? So this is in compression, which means that this is going which way? On the XY plane, is this
Going to the positive direction.
positive? It's going to the right. To the right, right? Not to the left. To the right. Sorry, we should be at robotics competitions right now. So
I know, right?
To the left. All right. So this is actually positive. So this should be positive. Does that make sense? And this is really 302.7. So then I just got to solve for it.
162.93.
Just make sure I'm right. 302 cos 29. Yeah, that's right. Okay. So here, wait. Why is it negative? Oh, fine. Hold on. Huh? Why did it take 5.7 off 308? Where was 308?
Why did you get 302.7?
Because that's what 150 divided by sine of 29.7 is. It's because I had 29.1. It's 29.7 for sine. I wrote the angle down wrong. So if you do 150 divided by sine of 29.7 and see if you get 302. You should. I wrote down the wrong thing, so people told me the wrong thing because their fault, because they're stupid, not me.
Blame it on me.
Well, it was my fault, so you should blame it on me. Is it? Is it 302? Good. Okay. I have a problem here. I screwed up my net forces in the x direction. One of them is negative. And what is it? And who can tell? What is it and why? Which one's negative and why is it negative? Well, obviously, we've already determined that this one's positive because it goes in this direction. So which one must be negative?
The other one.
Yeah. Why is that negative? Why is DC negative? Only look at joint C and you'll see the answer.
Because it's going to the.
It's going towards D to the left. Therefore, it's negative. Does that make sense?
Yeah.
Does it? Singleton?
But you redrew it on the bottom.
Yeah.
I only drew BCX on the bottom, not DC. Okay, so this is negative, so I'm going to move it over. I'm going to get positive DC or CD. I don't really care what you call it. Which is what? What's 302.7 times cos of 29?
262.93.
What is it?
262.9.
0.9.
Yep, he's correct.
262 point, I got 5, but that's because I use a bunch of different things. That's correct. And it's positive, therefore DC is in. Since this is positive, DC is actually correctly in tension. Okay, and this is 262.9. Whew. So now what's the easiest thing to do? I have a choice. This one's done, except for this. And this one's done except for this. So technically it's the same thing. So which one do you want to do?
D.
D sounds good. All right, I'm gonna erase this. Is that cool? Or we're almost done. I think it's cool. No one said anything.
There's someone
Yeah, trust calculations are a nightmare when it comes to math. All right, so here's.
You got like 3 different alphabets.
Which one am I doing? B or D? B.
One of the two.
All right, so I don't know this one yet. I do know this one's in compression. I know this one's in compression. I know this has a force of 437.67, and this has a force of 302.7. So I'm looking for this one, right? Okay. Let's see if I can. Oh no, I'm going to overrule you. This is a dumb one to use because I could solve for these using their components, right? Using their y components. There's technically 3 y components here, right? BD, this one and this one. Or
aren't you going to split them up into 2 triangles anyways?
I could.
Well, it would end up being the same thing, either one.
This one's in tension, and this is 500. I only want this one, right? So I'm going to sum them up in the y directions. So I'm going to do F is equal to what? What are my x directions? I have the load, which is 500. It would be plus dB, right? That makes sense. That does make sense. In which case, what's dB?
500. Oh, we're so smart.
All right, I could have gotten that using this one, but it'd be a pain in the butt.
Wait, how'd you do that?
Okay, look at B, right?
Okay.
All I want is the opposite of the original force, right? So I sum up all of the forces in Y. That would be the 500 pulling down and dB.
Right.
Now the dB has to be positive 500, which means this is correct and B is correct.
Oh, okay.
I know all the other stuff. I know this is 262, 262. I know this is 437, 437. Now I know this one is literally just positive 500, which makes sense intuitively. It's the one physically opposing the load.
So it's 500 on that beam itself.
On that joint.
So on B, the arrow going downward, would it actually be going upwards?
Huh?
On B, the arrow going downward, would it actually be going upward?
B would look like this. That's B. So B has 2 incoming arrows like that. And then A also has an incoming arrow, has an outgoing arrow. It's A. C has an outgoing arrow and an ingoing arrow. Like that. And that's it. That's what, C? Whew.
Okay.
Think of the direction of the arrows in terms of the middle of the beam.
The dangerous thought, but yes, theoretically that's right. The beam is more of a stopgap to get you from one joint to another. The beam doesn't actually have the force, it's more of the cable. So like, it's just a transfer. That's all it is. Just like if you dropped an explosion in water, you wouldn't measure the water, you would measure the force of the explosion in the thing it hit. Does that make sense? You don't care about the air or the water or anything that's passing through. You just care about A and B. That's what's happening here. So the member is just a glorified medium. Okay. So the members actually don't matter. Now they will once we get the material test. Because then the members can handle that force or they can't. So which is where material selection comes into play. Because if this force at AB has to handle 437, maybe it could be aluminum, but maybe it has to be like a thick piece of aluminum. Or maybe it could be plastic, but it would have to be like the world's thickest piece of plastic. Does that make sense? Yeah.
Maybe a joint within a joint.
What?
Maybe a joint in a joint.
It's going to be a joint within a joint?
Yeah.
I mean, it feels like a Snoop Dogg question.
Can it be joint substance?
What?
Well, you're saying like in the beam? You're saying here or you're saying here?
Like looking at it, yeah, like it was really going in acres. Like you could stay grounded on the house.
That's just a big hole. Then you just have a bigger hole than the other. Because you still have two beams stacked on top of each other. We're only looking at two-dimensional here. I have two beams. One is on top of the other and they're riveted together. Or screwed together if they're wood or something. Or they're not together and they're literally connected with like a biscuit or something if they're pieces of wood. But it's just a biscuit, so it's a little piece of wood that acts as a joint. So it looks like that. And then you shove one inside into the wood and you shove the other side of the other wood and you glue them together. And it holds it for torsionary forces. Okay, but it looks like a dowel, but a really fancy dowel. You have to buy an extra tool for it. I don't really care about. How does everyone feel about this? I'm assuming everybody just get on their phone or tweeting out their excitement.
Yeah.
You just put this on Instagram. I was like, I know how to do trust calculations now, right?
Yep.
Okay.
Ever so.
Yeah, I'll help you more with trig. Yeah.
Am I overthinking this, or like, does anything happen like because the arrow going downward for B and the arrow going upward for D? Does anything happen in the middle point?
There is no middle point. The middle point is the member. That's the piece of metal.
Okay.
We will on Wednesday. No. That's a step-by-step calculation that we will go through step by step. I want you guys to do it and I'll answer your questions, but it literally does what I just did. It has little boxes for you to say, oh, I want AB. And then I'm going to use ABY to get there. Blah, 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 blah. It's literally like connect the dots, but for trust calculations. Well, you can start it now, but I don't expect it to be even remotely done until Wednesday. You only have 10 minutes in class. Huh? This Wednesday. Tomorrow's Tuesday. Today's Monday. Yep. Today is Monday. Sorry, I should have started the lecture out with that. Today is Monday. Tomorrow is Tuesday. After Tuesday is Wednesday. Then we're all off for 2 days. Asynchronously.
Wait, we don't have school on Friday either?
No, well, it's asynchronous Friday.
Oh, well, yeah. But, okay.
We were in the building Wednesday. Wednesday's a normal day. We have 3 days this week that are normal days, and we have 2 asynchronous days instead of 1. Yes, Rachel.
Is next Thursday e-learning because of conferences, or do we just have it off?
What?
Spring break.
Going to April school.
I'm sorry.
Right.
Well, I get it.
You go straight into St. Patrick's Day, right?
No,
There's Easter break.
It's a joke. It's a joke.
How does everybody feel about your first trust calculation completion?
I feel like
I like that.
There's very much repetition.
This is how like the Japanese
A lot.
I feel like that's the trust calculation.
If you can do this, you can do everything in kinematics. If you understand this, you can do trig, you can do vectors, you can do resultants, you can do components, you can do it all. Yeah. Oh, sorry. Will it increase your score in the SAT? Absolutely.
Yeah, perfect score.
Will it get you a perfect score in the SAT? And then nothing to get you a perfect score in the SAT. Rachel, this will probably go. I'm trying to make fun of Andrew. I'm using it.
Who just got hit by a car?
I think that was the foreign language class upstairs. I don't speak English. I guess I speak German. All right. Does anyone have any? Hey, does anyone have any remaining questions on anything I've done here?
Why does it sound like someone getting hit over and over?
Nope, that wasn't anything that I was asking about. We're not going to go over this. We're going to go over a brand new one. We're going to, hey guys, on Wednesday, you will be responsible for doing your very own trust calculations on your own. Yes, you can work in groups. No, Valadio can't do it for you. Okay?
That could have been perfect.
Would you like the caps for your money?
I'm good. I'm gonna stop this. I'm gonna put it up online for everybody. Finally, I don't know what that's supposed to mean.
That's a yay.